So, welcome. I would like to welcome all of you to the Samueli School of Engineering 2015-2016 Distinguished Lecture Series. And today's lecture will be entitled The Why and How of Project-Based Learning and Its Impact. And it will be given by Professor Diran Apelian, who is the distinguished visiting professor here at the University of California, Irvine, and he's also the Alcoa Howlett Professor of Engineering at Worcester Polytechnic Institute. Professor Apelian has served in leadership positions at both Drexel University and WPI, including department chair, associate dean, and then he joined WPI in 1990 as its provost. He is currently the director of the Metals Processing Institute at Worcester Polytechnic Institute. MPI is an industry university alliance dedicated to materials processing with over 90 corporate partners. Apelian is credited with pioneering work in various areas of materials and metals processing during this last decade. He has worked on sustainable development issues, particularly resource recovery and recycling. The recipient of many distinguished honors and awards, he has more than 700 publications to his credit, 16 patents, 15 books, and serves on several technical and corporate boards. With his colleagues and students, he has founded 4 companies: Material Strategies, LLC, Battery Resources, LLC, Melt Cognition, LLC, and Kinetic Batteries. He is a member of the National Academy of Engineering, the European Academy of Sciences, and the American Academy of Sciences. In 2016, the prestigious Bernard Gordon Prize for Innovation in Engineering Education was awarded to WPI, with Professor Apelian named as one of the Institute's 4 recipients. For those of you who don't know what the Gordon Prize is, it is essentially the highest honor that anyone can receive in engineering education globally. And so it's akin to the Nobel Prize for Engineering Education. And so it is, we've had the joy of having Professor Apelian work with us over the last few quarters, and he's currently leading a strategic planning effort for the school, and he is doing a magnificent job, although he might be working the committee really hard. But the impact that he's going to have on this school and this program is tremendous. I value his input as both a counselor and a friend, and I give you Professor Diran Apelian without any further ado.
Thank you, Greg. You're giving me more credit than I deserve. The team that is working on the strategic planning committee is some of the most inspiring and dedicated colleagues I've worked with, so it's been a pleasure. I know it's finals week. A lot of people are tied up with a lot of things, but the important thing is that you're all here, and I've got a story I want to share with you. And so thank you for being here. So I've titled it The Why and How of Project-Based Learning. And Greg mentioned about the Gordon Prize, which really, I'm only one of the recipients. My 3 colleagues who really deserve the credit: Art Heinricher, who's the Dean of Undergraduate Studies, Chris Wobe, used to be head of chemistry, now she's Dean of Undergraduate Studies for the first year, and Rick Vaz, the Global Program Director. The reason I was one of the recipients because in the 1990s, when the budgets were really being cut dramatically, and I was provost, I made sure that the project-based learning was going to get the support that it did. So I worked very hard to get the resources to be sure that we do what we must do. And thankfully, it survived and it became an important signature piece for the school as well as the university as well as engineering education. So the storyline. I've broken this into three parts. First, I want to tell you about the context in which we're living in, some of the things you've heard from other thought leaders. I've heard a presentation from Dean Washington at the 50th anniversary about the grand challenges. Some of it is embedded in there, but it's a different take in terms of what we need for the 21st century with respect to human workforce. The second part is what we need to do, what needs to be done. And the third part is what is being done by many universities, but the third part is really the story at WPI, what we're doing. So I'll share that with you as well. And then hopefully we'll have time for some Q&A. It is a given, I think, and hopefully you will agree that we're going to be needing a large number of people who will be making things, creating things, and innovating things. If you look at the stats, engineering graduates today command some of the highest salaries, and there's a reason for that. The other thing that we're witnessing and observing is that rapid economic development in the world's most populated countries are going to require a large number of engineers. So there's a need, there's a demand. But the world is changing, and the world is continually changing. We're living now in a world whether it's flat, if you look at Tom Friedman, but also it's very spiky. If you look at the urbanization, what's happening in the world, about 70% of the world is going to be living in urban cities, in large urban cities in the next 10 years. But our economy is global now, exponential and entrepreneurial, meaning that the way we are educating people, our students, for the 21st century may need to be different than it has been done in the past. Connectivity, or I should say unprecedented connectivity, as well as the globalization of the world economy, has really changed engineering in ways that we have not witnessed before, especially manufacturing. Many corporations are able to locate engineering talent and manufacturing where it's cost effective. It's no longer just a skill to know finite element analysis or CAD or whatever. So there are some challenges. So the traditional advantages that were based on location and culture are vanishing. So we need to educate a large number of technologically proficient people, but also we need to provide an education that prepares our young engineers, our graduates, to work in the modern world and to compete successfully with peers educated in other countries. I want to emphasize with peers educated in other countries, the cultural aspects, the global aspects, understanding how to work with people with different backgrounds and different perspectives. Now look at the stats. Some of you have seen this. Unfortunately, I picked the wrong slide. I just noticed it actually. I didn't get the 2014. I got the 2010 there. But the sad part is that it's not very different. So it's still relevant. 3 different countries or continents. You have the US here. You've got Europe in the middle, and you got Asia. What you'll notice is 2 colors, the natural sciences and the red engineering. 4.5% of the US population is engineering, natural science a bit higher. But if you compare that to Asia and Europe, I think the numbers speak for themselves. So we do have some challenges there. The other thing is the societal perceptions of engineering. And I'm not talking about only in the US, I'm talking about globally. In the US, if you look at our data, only about 20% of our graduates are women, just looking at the gender. 20% are women, when in fact it really should be more like 50%. If you look at other disciplines like medicine or law, you have close to 50% enrollment in the University of Women. So if engineering could achieve a 50-50 ratio, I put keeping the guys there in parentheses, in as a gesture there, but I think you're definitely going to keep the guys if you have a 50-50 ratio. That's not going to be a problem. We would see a very large impact in our workforce in that sense. Our student body is also changing, and significantly in the last 10, 15 years. Backgrounds of our students coming in, and I'm not just talking about WPI, this is nationally in our engineering schools. They're coming into engineering with not as much hands-on knowledge, but often with extensive computer experience. The faculty, of course, and again, not a UCI thing, in general, we complain that our students don't work as hard and they don't measure up in ways to the previous generation, et cetera, but some things don't change. Back in the Greek, Socrates said, youth today love luxury, they have bad manners, contempt for authority, no respect for older people, and talk nonsense when they should be working. So, as I said, some things don't change. The data is telling us something different. Students today entering into college are more socially conscious. They drink less. They get higher test scores than we used to 20, 30 years ago. And their attitudes are different. They're very optimistic. And again, those of you who teach undergraduates, especially first-year students, probably have noticed this. They're optimistic. They are team players. They're cooperative. They're collaborative. They're quite respectful of authority. They like their parents. They call them. They go on vacation with their parents. And they're smart. And they believe in the future. But more importantly, they want to make a contribution. They want to make the world a better place. And in terms of historical perspectives in the context of this presentation, if you look at the 19th and the first half of the 20th century, take the Industrial Revolution. And if you look at the major advances that were made, whether it's textile manufacturing, whether railroads, the Brooklyn Bridge, there were such incredible achievements and accomplishments that were made by engineers. And we call that era, the professional engineers who had mathematical, had tremendous attributes to make things happen. They created things, they made things. As Debye and Lowy and X-rays, and we began to look inside the atom and quantum theory, the scientific the attraction of science and the scientific theory sort of creeped in, and that's the era of the scientific engineer where, in the 60s, for example, innovated by the Sputnik, nuclear energy, we became much more interested in science-based. Nothing wrong with that, but that's the transition that occurred from the Industrial Revolution to the 60s. That happened to a large degree at the expense of design content. And in the early 90s, it became clear that science was needed. Many schools started to emphasize non-technical skills such as communications, design, etc. In the 21st century, I have a premise, and I maintain, I think many of us agree, is that the skill will no longer be a distinguishing feature that commands high salaries or demands in the marketplace, but rather the ability to identify need, identify a problem, identify a need, and find new solutions, and to make things happen is what's going to make engineers successful. So, the 21st century we call the entrepreneurial engineer society or century, or the innovation century. And if you just do a very quick analysis of the major corporations that were founded back in 1917, you look at the Forbes 100 list, only 18 of the 100 have survived. And many of them did not even exist. And that's just a small list. It could be much larger than that, meaning that there are some major changes going on. So hopefully that provides some context of engineering education should not be, looking at all the things I've just talked about, and I could spend a lot more time in each one of those, cannot be what it was 50 years ago. Engineering education needs to evolve, needs to change. So what needs to be done? One of them is how we recruit. Those of you who are not engineers in the room, we have our professional societies. We have IEEE, which is the electrical engineers. We have American Society of Civil Engineers, ASC, American Institute of Chemical Engineers. We have TMS, the Materials Society, ASM, etc. Each of these professional societies has a different message in terms of what engineering is about and why you should be an engineer. The message is actually quite fragmented. So we need a unified message, and actually there are discussions at the National Academy right now in terms of how do we do that and how we coordinate and execute that. I'm sure you've heard colleagues give a talk about why you should go into engineering, but then the second sentence is that it's very difficult, it requires a great deal of resilience, that it's difficult, you'll make it though, hang in there and work hard. When people from medical schools recruit students to the medical school, they don't talk about that you're not going to sleep too much. They don't talk about how much debt you're going to have and how long it is. They talk about that you're going to heal people. You're going to solve a problem. You're going to help people. We need to change that conversation. That's a longer story, but that's certainly one of our issues. The other issue is when it comes to manufacturing, there's this image that it's dirty. Well, it's not. Not necessarily. And I've got a lot of colleagues and friends who are engineers, and the ones that have this wonderful life are manufacturing people. They have companies, So that image has to be changed. The other one, and actually this happened this morning. I'm staying here at the hotel where one of the light bulbs wasn't working, and it was bugging me, so I actually called downstairs to get a light bulb, and the woman said, I'll get engineering to come up and take care of you. I said, wait a second. I don't need an engineering to come up and change a bulb. So I'm actually going to be writing a letter to Mr. Marriott about that. So the image has to change. Now, I came to America at the age of 15, so I grew up overseas. And in the Middle East and in Europe, both parts where I lived, engineering was seen as a profession where you could be a CEO, a prime minister, a leader in the country. And the Polytechnique, which is a French word for polytechnic, the English, of course, being polytechnic, had a different meaning and a different connotation, and still to this day does. For example, Napoleon, when he first formed these great schools, it's called the Grandes Écoles in France, and Laplace was actually on the board on the very first school. The vision was that they were going to produce engineers or graduates who not only are technically savvy, but they understand the human dimension, they understand history, they know how the world works, and they can lead people. So that notion is not a new notion. It was back then during Napoleon at the Grandes Écoles. So we need to go back to that. So part of the message is, what is engineering all about? It's not about commodity engineering, but rather the entrepreneurial engineers, the Jack Welches, the Wozniaks and others who have made some great things. It's about creating our physical world. And it's a very simplistic way of presenting it, but I have to tell you that I've done this presentation on the next slide to a bunch of audiences, particularly parents who are not in the field of engineering, but they're looking at their sons and daughters in terms of what they should be doing, or young people at the age of 15 or 16. And the story goes something like this. Our world can be thought about into two segments, our physical world and our cultural world. That's that ordered over there. And that, you study things and you create things. And in the study part, there are the humanities for the cultural world and the sciences for the physical world. And the arts is the creation part for the humanities, and engineering is really the creation part for our physical world. And that's actually it's a message that resonates and gets people excited. And if you present it that way, it opens up all kinds of vignettes in people's minds in terms of what the opportunities are in the field. The field of engineering is also changing. You know, the very quadrant on the far left, right, on the left, far right, 4-speed size. Those are the kinds of things that, you know, I remember when I was an undergraduate. But over the years, as things have evolved and the world has changed, you know, our language is changing. Engineering is not what it used to be. It's more systems oriented. It's more converging. And it has a lot more biology in it than we had 40, 50 years ago. So you have basic engineering, you have engineering systems. We need to change the conversation and convergence with the biological engineering. So these are some of the things that need to be done. And the other one that I've just threw in based on a conversation we had with our colleagues yesterday is that when you look at the grand challenges, that some of the major issues of our society in the 21st century is going to be how do you sustain development? How do you sustain the energy needs? How do you do mobility? And all of the things that we're using with materials, how do you recover, reuse, and remanufacture and recycle? So there are some, but you know, this is a great story in terms of opportunities. If I was 15 or 16 looking at this field and I was presented in this way, particularly with this slide here, you know, it's quite enticing. So change is the universal constant. I know we have colleagues, I certainly have colleagues back at my university and other universities where they haven't really realized how critical this is and how fast the world is changing, and that we also have to change our ways to ensure that we track the students, but also we prepare them for this 21st century. So what do we mean by that? What does in the short term engineering education has to do? You got to teach the students, of course, the basics. That's a given. That's not even debatable. So, you know, when we say that you got to do these things, which is in the second bullet there, that have the students think like engineers, meaning we got to teach them how to design. We have to teach them asking questions to why we're doing this. Who's the customer? Who's going to need it? Who's going to use it? What is the need? What's it going to cost? What are the impacts on our society and environmental? If I make a decision, a technical decision, what is its implications societally? How do I communicate this? How do I become an advocate for whatever it is that I'm working on? Do I let the lawyers do that, or do I do that as an engineer? So I'm not saying, and those of us who are really doing this project-based learning, we're not saying we're going to give up the basic knowledge, the fundamentals, but complement it with the things that are really, really critical. So we're living in a world, it's not like what you know, it's whether you can get it done. So, you know, it's much easier to test and evaluate the first one, and unfortunately, you know, we've done it, we've paid more attention to the first one than the second one. So the professional, the non-technical professional skills are really, really critical. Engineers are not only resilient, but they're resourceful. They'll figure out ways to figure things out. So we've always learned what's needed and what we need to know to get the job done, and we get it done. And in the 20th century, the laws of physics were the limiting factors. I can give you lots of examples. You probably can think of them yourselves. But really, as in this 21st century, the laws of physics are not going to be the limiting factor. It's going to be the societal issues. And I would even submit to you that for engineering, the social sciences may well be so-called the physics of the 21st century. Understanding how our decisions impact others and understand how our decisions are going to be executed are going to be very important. So in the short term, what do we need to do? We need to promote the role of engineers as creators of our modern civilization, not just problem solvers. Make the first year as exciting as possibly can be. I know there are some efforts here and initiatives under the leadership of Dean Washington and colleagues in engineering that you're doing that. but that is absolutely the right thing to do. And blend strong technical preparation with creativity and entrepreneurship, including communication, skills, and understanding of what the customer needs. I'll go on. Develop programs that the student can identify with and programs that excites them and inspires them. It's got to be fun. It's much easier to learn when it's fun than when it's treacherous. Global awareness and experiences is part of the preparation of every student is another aspect. Account for the fact that the showstoppers, I've already talked about that, the social sciences have to be incorporated. And teaching fundamental sciences and engineering with a focus on providing the foundation for continuous learning. It doesn't stop when you graduate. So in a nutshell, those are the foundations of why we need to make the changes. Now in terms of how do we do it? This will be a very WPI-centric story because I can only go on the things that we've actually done and give you some specific examples. One of the things that took, when I was provost, one of the things that took about 2.5 years, and you think this is something we could have been done in a few hours or a day or at most, was the College of Engineering, the Humanities and Arts, the Sciences, and Management. So you got a faculty, 4 different faculties with very, very different perspectives, coming together as a whole, the faculty as a whole, to agree on what are the outcomes of the education experience of our students, whether they're coming out of biology, they're coming out of engineering, they're coming out of management, or they're coming out of drama. And this took, but it wasn't really the end point. This is the end point. It was the journey to get there. Just like in our strategic planning team, the conversations and the journey that we're going through is just as important as what the final destination is. So the things in red are the ones you want to focus on. I'm not going to go through them, but those are the 10 outcomes that we actually have metrics for. We measure, we evaluate, it's codified, it's in the system, it's in our DNA. But there are certain words in here, you know. Be aware of how one's decisions affect and are affected by other individuals, meaning in other countries or in other places, separated by time, space, and culture. That's where the Global Perspectives program comes in. Ethical standards, the interdisciplinary approach, the connections between disciplines. I have just sent a copy of these slides to Dean Washington's office, and you certainly have my permission to make it available to the faculty. So what we tell our students at WPI is that we got 2 goals for you. And we do this first year when they're coming. You got to be an expert in your field. You're a chemical engineer or mechanical engineer. You got to know your discipline. You got to master the content. And you got to get the answers right. It's about the major. But you also have to solve real problems where it's a dichotomy, you know. You may not get the answers right. In fact, failure here is not a bad thing because you got to learn how to fail quickly and get back on your feet and do it again so that you're successful. It's undisciplined. You don't even know when the exam is. It's about learning, about courage, and working with other people. So when we say project-based learning, what does it mean? What constitutes project work? It's got to be authentic, open-ended problems where it's fuzzy. It's not well-defined. It's complex. It's not well-defined. It's messy, interdisciplinary. It's not just a mechanical engineering or electrical. It may have other disciplines. The professor does not identify the goal, the methods, the criteria. Rather, the students do that, which is a bit different, huh? The problem is well-defined, or not well-defined, it's well-articulated, even though it's open-ended and messy, but the goals and the methods are done by the students. Synthesis, analysis and synthesis, both of those are really emphasized. But also, students out here are working in teams. They're not working by themselves. Teams of 3 to 4. So communications and how does a team succeed is very different than what they did getting into the university. You know, if you think about it, you know, you take the SAT exams, you take your essay, your high school record, everything is a personal achievement. But when you're working on a team, and a conversation with a student goes, you know, the grade you're going to get on this project is going to be the grade of the lowest performers on your team. That's a very, what? How does that work? Well, you have 3, 4 of you, but one of you is not working out as well, and their grade is X. Your grade is going to be X. So this knowledge or this notion that I've got to be sure that every team member on my team succeeds because I'm not going to succeed unless they succeed is a paradigm that they're not used to. But you've got to get that, and many of us have learned that over the years in our work that, you know, but it would be wonderful if you learned that early on when you're a young person. So objectives for project-based learning, applying knowledge to complex problems. Some of these are repetition, social and cultural context, learning new topics quickly, communication, interaction, etc. Ben Franklin, I just read a book. I read his An American Life this summer by Isaacson, which is a great biography of Franklin. He said, "Tell me and I forget, teach me and I may remember, involve me and I learn." And the more involvement, the more engagement, of course, the learning experience is much more meaningful. So our projects are essentially one every year. First year is the Global Problem Seminars, GPS. There's a second project in the second year, third one in the junior year, and of course a fourth one in the senior year. The QP means qualifying project. You cannot graduate unless you have done this project. You can't graduate until you've done that project. The M is in your major. The I is interactive interaction between technology and society, the social sciences and engineering. The humanities and arts is, I think, self-explanatory. And the first year is the only one that's not mandatory, but it's becoming, we had a lot of, when we first introduced GPS, there was a great deal of, not revolution, but a great deal of torment and anxiety that this is going to take away some courses that the chemistry department offers or courses that the physics department offers. What are you going to give up to do this? A lot of conversation. So we piloted it. And we did it now for 8 years, and 70% of the first-year students are taking it. It's by choice. They don't have to take it, but 70% are taking it, and next year it's going to be mandatory. So it took about 7 to 8 years for our colleagues and faculty to figure out, wow, this is really working. The students actually are better off by taking this than, you know, having another specific course. So we have adapted it. So, so those are the 4 projects, one in each year. And remember those outcomes, the 10 outcomes, which I'm not going to go back to the slides. We actually measure it. So in the first year, the first year project, the second year project, the third year project, and the fourth year project. And we have lots of data on this, which I can certainly share. By the way, we have classes too. It's not just projects, but they're half semesters. They're 7-week terms. You can only take 3 courses, not 4 or 5, 3 courses only. And the courses meet every day. So when I'm teaching the GPS course for 2 terms, my family loves it because I cannot travel. So it's 5 days a week, 3 courses. They take 38 classes to graduate, and I'm going back and forth because I think this thing is discoloring the slides. There are no prerequisites, so we don't say you can't take this course till you've taken this and this. They'll figure it out. And we give lots of opportunities for risk-taking, very flexible distribution requirements, and a bit strange grading system. You know, you can't fail. There's no punitive grades. So the grading system is only A or B or a C or what we call NR. There's no record. It doesn't show up on your transcript. So if you fail, you know, the F that you know, it doesn't show up on your transcript, so that means you got to take it again. You got to pay for it, of course. So there's a penalty there or motivation not to fail. So the grades really represent achievement, And a lot of students take courses that they're afraid to take perhaps, but they know that if it doesn't work out, they're not going to be penalized for it, so they take risks. Unfortunately, sometimes, explaining to like this audience here what an NR is, so that's a communication to the rest of the world can be a challenge sometimes, but it's working. So in a nutshell, the balance of course and projects, 38 courses, 3 required projects, that's how it works for those of you who worry about how this thing is. So just a few glimpses of each of these projects, and I'm going to finish up soon. The GPS is the first year project work. It's called the Great Problem Seminars. It focuses on big, important problems. They're very interdisciplinary. They're on 2 terms, A term and B term. So when the first year students come in, September 1 till Christmas, they're working on this GPS course. A lot of writing. We don't tell them that at the beginning, so we don't scare them, but there's a lot. It's writing intensive, teamwork, lots of research, and it's real stuff. To give you some examples of I'll give that in a second, but the objectives of the course is to encourage critical thinking early on, engage the students early on, excite them early on, and essentially it's an ignition point. And they don't know enough, but once they don't have all of the technical know-how, but their creativity is there, and they're challenged by some of these large problems that we face them with. It gets them all excited and inspired, and they know the reason why they need to take those courses. So we did one course with Svetlana Nikitina, who's a French literature major in humanities and arts, who's my partner in crime. So it's very interdisciplinary. For example, when I talk about water in that course, I have lots of technical data. She'll talk about water from a humanistic perspective as to what water means in various cultures, and et cetera. The last 2 years, we've been doing a course on Recycle the World, Recovering Earth's Resource for All Species for All Time. Very popular course with the freshmen. So to some extent, we call it a Great Problem Seminars, but to some extent, it's a GPS for the students, because many of them have written to me after several years that, that course really was foundational to me because I figured out what I wanted to do in my life. So it's like the destination point, and it gave me a framework. It helped me figure out what I want to get done with my life. And the rest of it was just a pathway how to get there. So the humanities and arts, we don't have a Chinese menu where, you pick 3 from this column, 3 from that column to make sure that you meet the requirements, but rather we have a project. And that project is, you got to take 5 courses that are thematically related to the project that you're interested in. And there's a list of about 14 different areas you can do it in. And then you have to do a project. That could be an inquiry seminar, a report, or a paper, a book. It could be a play. A lot of students, we have a very strong drama program where students write plays and perform. Or it could be a language immersion, Chinese, German, as well as Arabic. The IQP is our signature piece. This is what the juniors do, and this is a project that's done that looks at the impact of technology on society. And many of these projects are done overseas. The objectives there are, again, research skills, problem solving, critical thinking, communications, teamwork, and it's not just a course, it's 9 credits. Okay, so it's 3 courses, A, B, C. Teams of 3 to 5 students working on all kinds of projects overseas. I'm going to skip this one. I'll show you this. We have 42 or 46 project centers now. It's a very large infrastructure that's needed to support this. And about 600 to 650 students are going overseas every year in their junior year. We have 1,000 students in every class. So it's about 60% to 65% of students are doing a project overseas. U.S. population, I think the number of passports issued is about 23% of the U.S. population. 65% of our student body has U.S. passports. For example, the Bangkok Project Center is a very active project center. We've had a lot of projects over there with NGOs. These are all sponsored, by the way, by, the sponsors pay for the infrastructure, et cetera, NGOs, the governments, corporations. Some examples of these, in Namibia, a very strong program there, erosion and flood control and formal settlements. Another one in Melbourne with a deaf school. Institute of Fisheries in San Jose, Costa Rica. I think you can see these, the rest of them for yourself. Some pictures of these. By the way, these are transformational experiences for our students. When they come back, they're different people. How do we do it in terms of the curriculum? Remember the A and B term, the half semesters? So we have 2 semesters equal to 2 terms. They'll take 3 courses here in A term. This is the junior year. In B term, 2 courses, and then there's a social science course in preparation. So it's a requirement. Then they'll go 7 weeks immersion, full immersion, no courses in Bangkok, but a lot of preparation has already been done ahead of time. They know what they're going to do. They do it. They come back. What I don't have here is reflection. There's also a reflection piece. What we have done differently. What did we come out of it? So that's how it's done. That's how we were able to get this executed. I think some of these things are already apparent by now: student learning, global preparedness, cultural savviness that comes in. The benefits are huge. We have 38, close to 40% of our student body is women now. And this program appeals a great deal to women. Of course, the faculty benefit a great deal from it, and also the multidisciplinary collaboration. The MQP, I'm not going to spend much time on. It's very similar to a senior design project. There's 9 credits, though. It's not just a course. It's 3 A, B, C, 3 terms, teams of 3 to 4. It's a capstone design. And just some examples. They all have sponsors. So there's a customer. We have a big project center with Gillette, with the National Science Foundation in Washington, D.C., et cetera, and some are overseas. We have one in Hungary, in Venice, in China, et cetera. So essentially, as I'm bringing this to a closure, we really are practicing theory and practice together. That's what we're doing, theory and practice. And it's learning by doing. And it's actually exciting to do that. It's not just taking the theory, but actually doing it every year, and also building collaborations with your colleagues, learning together. And Ben Franklin didn't say that. Maybe he stole it from the Chinese, but essentially the same message. And for those of you who are Red Sox fans, even though he was not Red Sox, he has some great sayings. But in theory, there's no difference between theory and practice, but in practice there is. Lastly, we've also seen a transformation of our faculty's role. We no longer dispense information, authority, and expert, but rather we're peers with our students, and we learn together. We're more of a coach. We're more of a facilitator of the learning environment and monitoring inquiry. In fact, I don't have enough time to go into this, but I was just doing some analysis of how the great universities of the world got started back in 1400. The students didn't go to class. I didn't know that. Did you know that? They read the great books. If you were in Christ College in Oxford, you had a whole week off. You read the great books. They were assigned. And that was the Google of those days. And then you met with a professor on Friday afternoon for a couple of hours, one-on-one. And inquiry, just have discussion to calibrate the learning. So there's a paradigm there that could be possibly adapted today, where with all of the information that's out there, students can learn on their own, but then the role of the faculty will be changed. It's more of an inquiry monitoring. The students themselves, they don't listen and watch. There's not that much dependence in gaining knowledge, but they're creating and discovering independence, making knowledge. And Some of our lectures are not lectures. The information is already given ahead of time. It's more interactive and question back and forth. Chuck Vest was president of MIT, a very dear friend who is sorely missed, and then became president of NAE. He said this actually in the last couple of years before he passed away. He said, what is important in engineering education? Making universities and engineering schools exciting, creative, adventurous, rigorous, demanding, and empowering milieus is more important than specifying curricular details. So it's got to be exciting, it's got to be creative, it's got to be compelling. Much of the details of how to do it is written in this book that Gretár Tryggvason, some of you know him, is a big name in the field of fluid mechanics, and I put together, and I'd be happy to share that with you, those of you who are interested. So with that, I thank you for your attention, and hopefully I didn't put anybody to sleep here. Thank you. Thank you for asking the question. I didn't go through that. We actually have a whole tutorial how to work in teams. And it goes, I'll just give you some vignettes. I don't have the time to it. And I'll use examples. Because sometimes, you have, let's say you have 3 guys and a young lady. And the young lady and one of the guys, they're dating each other. So they like each other. And they're discussing a project that they're working on, and the young lady says something that doesn't really make much sense. What does the guy who's dating her say? That's a stupid idea, that doesn't make sense, or he is actually being very nice to her. We actually do those role modeling in terms of how do you critique each other, and how do you become constructive? Then we go through an exercise of interviewing each other as to who's going to be the facilitator, who's going to be the CEO of the team. So what is a CEO? So we explain to them we go through all the details. Who's the chief operating officer? Who's going to be the secretary of the corporation? You guys are like a corporation. You have to succeed. You got to win. And you're only going to win if everybody pulls together and you first identify what the strengths of each of the individuals on the team are and what the weaknesses are, because the last thing you want to do in leadership is to give somebody a responsibility that they're not going to succeed at. They're bad at that. Why would you want to put them in that position? So for example, if somebody's really good in graphics and making PowerPoints and graphics, heck, that person will do the graphics. If the other person is really good at writing, that person may take the lead in the writing. So, but that, I'm making it simplified, but that discussion of what are you good at? What am I good at? How can we come together? That takes time. But we actually go through exercises, role-playing, for them to be comfortable to ask those kinds of questions. And it's really funny, Martha. They get all dressed up when they do the interviews, because they all want to be the CEO, right? And but it's a good thing to go through. And also, how do you critique each other without being personal? It's not personal. Don't take anything personally. That's the first thing we teach them, And always thank the people who are giving you feedback, even though it is not pleasant to hear. Because those are the people who care. People who are not giving you feedback that's not pleasant, they don't care. They're not going to tell you the truth. So they get a consciousness and a sensitivity that, I got to tell you, for me, it took me a long time to get there. I wish I had it when I was 19 or 21, right? I'm still learning. So we go through those kinds of exercises. And I actually have a whole bunch of slides on that I'd be happy to share with you. Yeah, it's fun. But learning how to work together, but the other thing is that one of the team members is not pulling their weight. And that happens sometimes. So they come over, Professor Apelian, so-and-so, we got a problem. It's your team. You got to figure it out. I don't solve it. I said, have you had a meeting? Have you actually shared this with that person? Well, not, well, you got to do that. You got to face. So we guide them through it. We help them, of course, but not doing it for them. So they solve it. They actually solve it. And but those are experiences that you don't forget when you're 19, 20. It stays with you for life. Yeah. Answer your question? It wasn't like when I first got there, I think it was 12% women. So obviously it didn't happen overnight, gradually. In fact, if we can just have some fun here. So when I was provost, when I got the stats in my first 6 months, 12% women, that's not very good. So I had these focus groups of women, the women, I wanted to meet with them to find out what is it that we need to do to bring more women like them to the campus. And this is a true story. In one of the meetings I had 4 young ladies with me. They were very pleasant. Mom said, Provost Apelian, the reason I came here is because of the odds. I like it the way it is. That's the last thing I wanted to hear. And then the other one who was, actually I know this lady, I'm friends with her over the years. She was humorous, and she said, well, the odds are good, but the goods are odd. I remember that. So I think we did it gradually, but I got to tell you, the first year experience with the Great Problem seminars, on a serious note, where you present engineering as a profession whereby you can change the world and make the world a better place. Not that, you got to be good at math, it's tough and you may not make it. Just the other way around. All the attributes of the profession. And that's a compelling story, and it's true. We just have not emphasized that part of the storyline. And the social sciences, particularly in the IQP, the global programs, where the impact of decisions on the human dimension that attracts women a great deal, and actually influences the men as well. The place has changed. It used to be a much harder, edgier place with more women on the campus and a women president. The place is a much gentler place. I like it, actually. So. Amazing. I have a whole bunch of slides on that, testimonials where the students are viewed. I have a bunch of stats on that, but I didn't want to put it in because it would sound like a WPI propaganda. I forget which pay scale or what it was. The students that get the highest salaries from school, Dartmouth is actually number 1. And I think we're number 4, number 5. Colorado School of Mines is also there on that list. So employers like the people who hire our students because they're ready to run. They know how to work in teams. They know how to execute. They know how to get things done. And they know what questions to ask. But having gone for 4 years where they're no longer just sitting there taking notes and just passing exams, but rather active in their learning, where you're not requiring them that you got to take this course before you can take this course. It's for them to figure it out, because if they can handle it, why not? So it's that cultural, but I got to tell you, it did not happen overnight. It took a while for this to happen, so it's a long process. But many of the lessons learned are available, so you don't have to start from scratch. And the 4 people I showed you the pictures of, the 3 of them, they have a project-based learning institute that they actually do in the summer, and I think they've actually agreed to come here and do a one-day workshop, which hopefully we will do in 2017. Charnia and then Sarouche. at the beginning, it was not, you got to get it started. So at the beginning, it was difficult to get sponsors, but today I think about 60 to 70% of all the projects in the senior year, the design, are sponsored by a company. It's a hell of a bargain for corporations. Imagine having 3 or 4 students working on a problem, and it doesn't cost that much. Oh, the students cannot get paid, by the way. They cannot get paid while they're working for their projects. It's really just the infrastructural. So we've taken that out of the equation because that will change things and it will bias things. So students doing their projects cannot get paid. The company Gillette will sponsor the infrastructure. They'll have a project I think costs like $10,000 or 15, something of that sort. So it's not a lot of money, but for a company like Gillette, you got a problem, you got 4 students working not just for one course, but ABC, that's 21 weeks, right? And each student is working at least 10 to 15 hours a week. Just add up the numbers. That's a lot of work hours for 15,000 bucks. And they get some great results. So that's how we do it. And the word gets out. The other thing which I didn't put in is for the senior projects, remember now, between the junior year and the senior year, you got that summer. So with the corporations, once you start the relationships, again, it doesn't happen in the beginning, but there's a domino effect. They love the projects. They love the way our students are doing and performing. They say, well, how about if we hired 3 or 4 of them in the summer? So they'll hire 3 or 4 in the summer. Students have a job. They get paid there. When they come to the campus, they're ready to run, right? I mean, they know the people at the corporation. They can get resources. And some of these projects are really almost like master thesis. I mean, they're really quite, in depth. Sarush, good to see you. Not only my younger colleagues, my older colleagues too. You asked a very good question, the cost. The students, when they go overseas, they just have to pay their tuition, okay? Their housing costs, their living costs are covered by the sponsor. And in some, I don't know the number, but probably half of the projects, they have to cover their travel cost. But the other half are covered by the sponsors. For example, in Thailand, there are a couple of NGOs that have actually a building and a place for the students to live. The biggest issue, which I think you hinted to, is the security, safety, communications, and there's, I think, about 12 or 14 people as staff. So it's an expensive proposition. Administratively, you got to budget for it. So when we want to start a new project, for example, we have one in Morocco now, there was about a year and a half of legwork where people went there, visited, make sure how it's going to work, Wi-Fi connection, interconnectivity, all that stuff. So you've got it. It's not something you can't. It's not an amateur game. You have to have the infrastructure and the staff to ensure that things are well prepared. But the cost-wise, it's not an issue. The major issue is really all the. For example, when we had students in Thailand, when there was a coup, you remember 2-3 years ago? It was a nightmare. But, you got to do it. You got to do it. You have a question, David? No.
Well, the question, yeah, I was a little bit more curious too. Like, said that you're employers to give you
It's like excellence. You know it when it's, the employers like it, the students like it. It's, the word is out. I mean, it's hard to get into the place. I mean, actually, dismaying to me how many rejection letters, beautifully written rejection letters we send out. It's not. But we have a different mission. We're not a public university. It's a private university, so. But employers like it. I think the educational experience is a more fruitful, more meaningful experience. No, no, no. Because whatever is the basic engineering knowledge is, whatever it is, whatever field it is, whether it's a mechanical or a chemical, I'm not going to pick one. If you complement that with the things that I talked about, actually the basic engineering knowledge gets even more fortified. It's not this versus that. It's not like, CP Snow, the two cultures. It's really one culture elevating the other one. So imagine for a second what it would be like to have students that we graduate from our engineering school who are really good, pick something, they're really good in thermodynamics and fluid mechanics. I mean, they're the best. But they're totally ignorant about the impact of their decisions that they will make from a societal perspective. They're not savvy enough on the cultural differences, what it would mean. So is that success? However, if you can morph the two together without giving up something, but you can bring it in. Just like entrepreneurship. People talk about entrepreneurship. Not everybody's born to be an entrepreneur. About 8-9% of the population are going to be entrepreneurs. But the entrepreneurial mindset can be brought into the classroom, where you ask the question, why are we doing this? What's the impact? What's the value proposition? Who's going to benefit from it? There's value in that. So, okay. Hi, Gene. This is the sad part of the story. For our graduate education is very, very, very conventional. And there's actually in the strategic plan that our new president is putting in, she's bringing that part in. Because our undergraduate is so distinctive, why is the graduate education so conventional? And I think part of it is because of history and tradition, how PhDs are done and masters. But now what we're doing is in our graduate education, it's not done yet, but the plan is to bring in like an internship or not a co-op, but an internship experiential learning about things that are non-technical. I think I had a conversation yesterday about, every graduating master's or PhD should know how to read an annual report, corporate annual report. They should know what it means, what are the basic principles of accounting. Without, you don't need to take 10 courses, just, a couple of seminars. So things of that sort, yeah. Okay.
Last question. Oh, thank you. But just wondering guidance and involvement you have in project-based. So it's fairly student-driven. Teams will self-organize and somehow work this entire process by themselves. But how much of the faculty guiding them?
There's quite a bit. There's quite a bit of guidance by the faculty. There really is. But it's got to be not so overt, but more. There's a mentoring program, so a new faculty, let's say, they're coming in from another university as a young assistant professor. There's a mentoring program, and they learn. Like yesterday, when I went to see David. David invited us to go see the ME Systems Laboratory projects where the students had the robots. The faculty were not running it. It was the students who were monitoring and doing things. The faculty were. So it's similar to that. The faculty are there in putting the framework, but it's got to be propelled by the students. Well, thank you for your attention, and hi, Michelle. Sorry. Thank you for your attention, and thanks for coming.